Well, yeah. Hi, good afternoon to everyone. Nice to welcome you all in my home city. Today I'm going to talk to you about what core web vitals are and how they help you to understand your web performance. Previously, there was some discussion like, hey, how can you claim you have to have some credentials if you are the subject matter expert here? So actually, I can't promise anything like that because it's an area I've just been involved in during the last year or so. But I feel it's an area that is quite complex and that front-end engineers themselves don't understand so well. And during the past year, I feel like I understand this topic better than the majority of the front-end engineers I work with in my company. But my job is to elevate others, and I'll try to do my best. So today's agenda: quick intro what core web vitals are, how to measure them, and then how to just get started with web performance monitoring. Quick summary: so there are 3 metrics that Google cares about the most in Chrome web browsers. So largest contentful paint will tell you how fast the page loaded. INP, which is interaction to next paint, measures what was the slowest interaction on your page. And CLS, cumulative layout shift, quantifies how much your page jumps, basically, when it loads. And there are certain thresholds that Google has come up with that helps you to understand better if you're doing well or not so good. And some of those metrics can be measured like synthetically, which is the lab indicator, so there are lab metrics. And RUM is the real user monitoring that you can track from real user data. So LCP, largest contentful paint. So basically it's the largest element that's present in your viewport when the page loads. And if it's below 2.5 seconds, then Google thinks, okay, and indicates to you that you're good. If you go beyond 4 seconds, then yeah, you would see red numbers when you track this metric. And here, this green part visualizes then what in the page loading process are LCP candidates. And in the end, the larger element is loaded. In this case, it's an image. So that would be measured, how fast that piece of content would be loaded, and that would be then your timing score when this appears in the page. So to make it faster, you need to know how to basically optimize the critical rendering path of the image. In this case, it was the image, but it can be sometimes a block of text, a video. So you need to first identify what the LCP elements are on your pages, and then dig deeper to understand how to optimize for them. So don't be afraid. I was afraid for a long time of the performance panel in Chrome DevTools. But yeah, if you open up the performance tab here, then basically if you hit this reload button, you can load a performance trace of that page. And Chrome has made some real nice updates during the past years, and now you have this sort of LCP request discovery section here that enables you to find what the largest element was on the page, and here the LCP indicator as well gives you a hint, okay, when in the timeline the event happened that it got loaded, and then you would see all the other resources, images, CSS, the initial HTML, so what goes into that critical rendering path, and you would need to then analyze it a bit with your developers. Maybe later you get more practice and you're able to do that yourself better. And yeah, these red triangles are also interesting bits, so they hint at resources that are render blocking. So while they're being processed, then actually the main thread is blocked and nothing can be painted. So here the FCP happens after these are after are processed, and then later we can see, at least on this page, some later resources are downloaded that would again block rendering. So, on to the second core web vital, which is interaction to next paint, and measures what is the slowest interaction the user had on your page. So it's more of a RUM metric. You can, in theory, have automated tests that do multiple things, and then you could extract that metric through Chrome's APIs. So actually, it would be a quite nice idea to augment your automated tests to later give you a report, hey, what was the IMP for a particular page if we tested it, and maybe consistently monitor it. But it's more of a metric I either just sometimes monitor during manual testing. So one way to do that is if you, again, go to the performance panel and just start interacting with the page and clicking around or tapping around, because you can hook an Android device here as well, and then use the dev tools. So the first interaction I had was here, so it was very fast, 14 milliseconds. Then I had a larger interaction that came, again, every time an interaction was slower than the one before, then that would be the IMP element. So here, not element, but interaction. So here, one of my last interactions with a particular element was over 300 milliseconds, which is considered now bad, because 200 is the good threshold. So yeah, that gives you an idea how to use it even just for manual testing, that, hey, I got a new feature, let me try it out and see if maybe some heavy JavaScript or something like that is associated with processing that interaction. Yeah, basically, in order to process interactions fast, the browser needs to have its main thread ready to deal with the user input. But if it has any render blocking tasks, long tasks, a long task is a task that is quantified as more than 50 milliseconds, then yeah, your processing might be delayed just because it can't deal with your interaction until it finishes something else. So the JavaScript event loop and how JavaScript works is also something to learn more about if you want to get deeper into that. And finally, a third one, CLS, cumulative layout shift. So it's basically the aggregated score of multiple layout shifts that happen as your page loads. And Google, again, sets a threshold that if it's less than 0.1, then it's considered a good page from visual stability perspective. So here's a video, me loading the Nordic testing days web page, and you will be able to see how the page's layout shifts as the system font gets replaced by a web font when it's loaded. So here is the web font when it's loaded. So, and you would see how, the layout is shifting here because of the font change, and that will be then quantified in the layout shift terms. So in the performance panel, if you go to the layout shift section and highlight on this purple diamonds, then they would tell you what the layout shift culprit was and how much it contributed to the cumulative shift score. And this nice visual transition helps you to file a bug with that trace, and because you can totally save a performance trace and later attach it to a bug report, and then you can have discussions with your developers regarding how to improve it. But overall, I have to compliment Nordic Testing Days website's creator, because the total Lighthouse scores and the performance scores were super good. So yeah, kudos. And so the Core Web Vitals can be viewed as basically like KPIs from a higher business level perspective. You'll be able to reason with the business and tell that, hey, it's site speed, interactions, and visual stability. Pages jump. They understand this language. But there are multiple other smaller metrics that can be classified further by a predictor or enabler metrics, and that's more like a developer language. These terms, I think, were coined by Harry Roberts, and it's time to first byte, for example, is the time that takes from the server to give you the first byte of the HTML document when it's loaded. So this gives you a hint that if this time is really slow, then the LCP will also can't be quicker than that, definitely. So it gives you a hint like what to optimize for. And in terms of CLS, for example, a single shift, if that's already bad, then you know where to focus on. So, and the predictor metrics are kind of like, if you have a big JavaScript sizes, then it's already an indicator that if the bundle sizes are very large, then when they're downloaded, the browser will take some time to process these. So, tools, measurement strategies for web performance. So, I think I would want to relate with what Pekka earlier talked about. I don't know, most of you, I think, saw the previous presentation. So he talked about moving from quality assurance to quality assistance. So this is what I also experienced and adopted in my previous, companies or previously when that was my focus area. And I think that's also one thing that enabled me to look beyond just functional correctness and functional testing and get into quality attributes, NFRs, quality aspects, different names for similar things. So yeah, now if you have a breather, then you can go beyond and look and understand, hey, do you provide a delightful experience just beyond that it works? So one of the tools that is available to you and it's free is the Chrome User Experience Report. So here's a small link. You can later find it from the slides as well. But basically Chrome anyway, if you consent, I think, then it collects data on your behalf and measures these core web vitals, and it uses it for SEO purposes. So when ranking your page in the Google search, and you can get for your website a report like that and monitor how your page is being doing from month to month. So every month they release a new update. And you can measure it also from using other means like real user monitoring with services like New Relic or Datadog. So, because Nordic Testing Days page was so quick and fast and performance scores, so I needed to find a page that wasn't so performance. Unfortunately, Ministry of Testing's page wasn't as good. Of course, it has more content, but I saw a lot of the image sizes weren't unoptimized and so on. So that's why it was a good example to show that the performance panel can give you then the LCP information when you load it, and you can understand that it's slow and then dig deeper as you saw with the traces. And Chrome has a nice feature that here it's, I guess, not so, it's present. So the data I earlier showed you, the Chrome User Experience Report, it will also show the same data, this field data from the 75th percentile loading time next to what you just measured locally. So another tool that kind of combines this is, it's again the same Chrome User Experience data. When you visit the site called pagespeed.web.dev, and you can analyze your site's performance here. But besides just first quickly showing you the real user data that Chrome has captured, it will then also do a lighthouse audit, which is a synthetic monitoring now for your site. It loads the site and then gives you some of the performance metrics. Not all of these metrics are core web vitals. So again, I said there's the cumulative layout shift is, the largest contentful paint is, but it can't measure IMP because there were no interactions after the page was loaded by Lighthouse. But there are some indicators like total blocking time that enables you to understand, hey, I might have a lot of long tasks and my input interactivity might suffer. And what's good about Lighthouse is that you can export that data in JSON format, and if you use a tool like Lighthouse CLI, you can run these checks from command line and automate these in your CI pipelines, and then you have machine-readable code, JSON, that you can basically process with code and do fancy things. So when I first started, I just gave an AI a prompt and said, like, hey, I have these 2 Lighthouse reports. Please visualize this for me because I want to understand the difference. So this is kind of like a vibe coding approach, how you can build tools for yourself to visualize performance regressions and data. And my next prompt was, it was good, but then I said, okay, it's good, but just color code these based on Google's thresholds, and so on and so on. So I iterated with the tool until I came up with something like this. And this is basically a matrix that is interactive. I can click on all of these elements and understand more details of what's going on. So if I click an individual score, I plot how the time score has changed from release to release, from measurement to measurement, and I can interact with each individual measurement point to open up that full Lighthouse report. So that's something, I'm not a front-end developer, but with tooling like these days, with AI support, you can totally cook that up. So that's kind of the summary of what I recommend to get started when you want to use some tools to get into web performance and monitoring. So start with just local experiments and later move to CI and automate these visualizations. How to just go beyond just tooling is you first, in your organization, you better find a sponsor as well who cares about this and can influence the rest of the organizations to do something about these findings, to advocate for performance improvements. And then, having a set of developers who join you in this crusade also is beneficial, because they will also actually want to make those improvements, and they just want also business support to make these improvements, not just focus on new feature delivery. But the performance monitoring reports, in the end, you have to, you can still start easy with a complex matrix that I just showed you, but it's not consumable for business people, so you need to talk in multiple tiers, so you have to adjust your language when you talk about performance. And then when you have a report that is maybe more digestible with human and simpler things, like things are slow, things are red, then you can share that on a maybe after each release, once you've looked at these findings. Or when you do it in pre-production environments, then you can maybe pull the handbrake sometimes and say that, hey, we noticed the performance regression and we have to fix it before we ship it to production. And finally, some good resources that I recommend to check out. Google's web.dev performance articles go very deep into each metric and will explain to you what they are, what they mean, what caveats there are. There are multiple caveats because you can't measure that. All the browsers don't have like standardized support for these metrics, so that's why Chrome has adopted, Chrome is the best one to use, at least for now. And the webperformance.now conference videos are free on YouTube. I think for web performance, it's the best conference to go to. The ticket sales actually start in May this year, so I really want to go. I've looked at all the videos from past 2 years, and the content and speakers are awesome. And tickets also, I think, are not so super expensive. And finally, like really interesting resource, not just about web performance, but in general about the state of the web, is the HTTP Archives Web Almanac. So they've analyzed millions of websites and what kind of technology they use, how fast do they load, and well, there's a bunch of aspects about caching, about libraries, and many detailed things that make you smarter if you go and look into that. So that's cool. That's it from me. Thank you. Do you have any questions?
Thank you. We are open to questions.
Thank you for a different topic today. And I wanted to ask before because you mentioned that you only do this kind of metrics with Chrome. Did you notice that if you improve something for Chrome, that will also be improved for other browsers, or do you have any different metrics that applies for other browsers and are not too important for Google? Can you compare them in some metrics?
Mm-hmm.
Thanks.
It's a good question. So a few metrics I think are standardized, like the first input delay. So I think Safari or Firefox has support for that, but you can again read it from the Google's guides. Not just Google's guides, but it's. I think they cover other browsers as well in those regards. But for the core Web Vitals, there's no uniform support for this, just because of the nature, how the browser engines are built, etc. So I think that's one of the reasons. But maybe in the future they will try to standardize this. But in my experience, I would still say that most cases, if you optimize then your JavaScript bundle sizes and your image sizes, and you improve your layout shifts that you observe in Chrome, you would also see that happening in the other browsers. And you can just maybe even do a quick manual test and verify, hey, if I made that change, does it appear also faster in those browsers?
Got one.
Hi. So when we use this Google page speed, and there's this chunk of data with yellow warnings and red errors. So some time ago, I was very interested in understanding those errors, and if we can fix something from that, and that can affect our metrics. So does that happen? And another was the maximum I used to get was the reduce unused JavaScript. And when I asked one of the developer for the help, and he was like that we already use defer, and for GTM we use async, but it will not get fixed, not all of them. It is just like that with GTM. Do you think we can fix that? Or will it affect the metrics?
Okay, so I think I'll try to break down. There were two questions. The first one was about just yellow
and
those
red
hints,
errors,
if you don't know, then actually below the Lighthouse report, after the metrics, and maybe if I go back a bit, below there are actually hints like what you can improve. So then it really depends, yes. So having these conversations with your developers does make sense. When you try to, and when something is yellow there with the yellow arrows, it does make sense to look over those. Not all of those will be your top one priority to fix. So you have to think from business perspective. Do these scores, there's just, in the end they're just scores, but you have to think how in our business context they matter. Is layout shift important for our customers? Maybe it's not. Is this page loading speed? Maybe input delay is critical. But I would say with the example you brought about, hey, your developers say all of our JavaScripts are deferred, so it means they are the JavaScript files start loading only not later, so they're not synchronously blocking the rendering of the already to get a very fast contentful paint. So they're kind of happening later after the DOM is processed. So I think the unused JavaScript still just means that your bundle sizes are too big, that they contain JavaScript code that's not really executed on that page at that time. So it might mean that, hey, you could maybe make those JavaScript files into smaller chunks and then lazily load on demand when you interact with something later, or scroll, the viewport down or something like that, or switch to another page. Maybe you have a single page application and you don't need to load everything right away.
Thank you.
Thank you. That was fast. So you mentioned it's important to find a sponsor and to recruit developers, but it makes me feel like you're competing with the resources in the organization to get this done. But it must also be a requirement somewhere or a team that's taking care of this. Or is that happy thinking, wishful thinking?
Maybe I didn't hear, it was quite a bit quiet for my ear here, but you're saying like it's hard to maybe find people because they also have other work to do and you're competing for other resources, and how to maybe avoid that or overcome that hurdle. Was that the question? Okay, so I've seen, for example, in my experience that it's just, you can start with just lunchtime conversations and talks that, hey, I did this thing, I found these insights, should we do something about that? And then some developers will go, that's interesting. They're naturally curious to solve problems. At some point, they might say, okay, it's a bigger problem, I can't deal with it, I have my other product work coming. So maybe, yeah, that's bad. So you would need a sponsor who's maybe higher up than their manager, and then they would get the buy-in from the business that it's okay for those guys to maybe look at performance data once a week, and then create those tasks for those teams who are responsible for those things. Because I think one of the challenges is that bigger companies, with the micro front-end architecture, a lot of teams work on individual pieces. So on a single page load, there are components that belong to multiple teams, so that page-level ownership is sometimes missing. So it's hard to find that, hey, now the page loading, holistic experience is suffering, that no one cares enough. So you then have to go through the higher levels who do care to get those individual people and teams to then make those fixes.
But I think this also comes back to what Lisa was saying yesterday, that like when you find a problem, you need to find the person who can help solve it and convey the message in a way that they understand. Right? Questions? Getting a bit calm here.
Yeah, I think people look like they need some coffee, don't they?
Yeah. So let's give the people what they need. And let's give Risko a big hand.